So, order of operations, PIMDAS, please excuse my dear Aunt Sally's. One of my students made up purple elephants munch daisies all Saturday. So whatever works for you. It can be a little bit confusing though because it's PIMDAS, so people go parentheses. Because it's not just parentheses, it's any grouping symbol. So it's parentheses, it's brackets, it's absolute value bars, it's braces, brackets and braces. It can be things underneath the square root that need to be done. It can be things on either side of a fraction bar. So anything that groups numbers together is considered a parenthesis, even though it's not an actual parenthesis. So really it should be a G and not a P because it should be G for grouping symbol, but then that would be GEMDAS, and I don't know even what you'd use for, please excuse my dear Sally. So anyway, exponents come second, and it's not just exponents though, it's also roots. So if you had something that needed to be squared, you'd square it, but if you had something that you needed to take the square root of, you'd do that next too. So those two have the same value. And then here's where it gets really confusing, multiplication and division. A lot of people take it very literally, and because the M comes first, they feel like they have to do all of the multiplication first and then go back and do all the division, and that's actually not true, and that can give you the wrong answer. Multiplication and division have the same value or the same weight. So like if parentheses are the king, because they come first, exponents are the queen, multiplication and division would be like the princes and princesses. And they have the same power, same strength, same value. So it's not that multiplication comes before division. They come at the same level after exponents and before addition and subtraction. And you do them in order as you read the problem, so you go left to right. So if multiplication comes before division, you do that first, but if division comes first, you want to divide before you multiply. And then last is addition and subtraction. So these guys would be the jesters in our court of math. And those you would also do in order as they appear from left to right, but it's not as critical because addition and subtraction, it won't matter as much if you do them in the wrong order. But multiplication and division, if you multiply always before you divide, you can get the wrong answer. So be really careful about that. That's in order from left to right. Questions on any of that? So we have this lovely, beautiful problem. We have no parentheses, so our first step is going to be the exponent. And so I'm going to square that 2. Oh, that divided by is awful. Okay. Next, divide. So 8 divided by 4 is 2. And last, I'm going to subtract and then add. Um, 16 minus 2 is 14. Plus 14 is 28. Okay, step 1, this time we're going to subtract inside the parentheses. Okay. I've got division and I have multiplication. I'm going to do the division first. Now in this particular example, this division and this multiplication, because they're separated by addition, it wouldn't have been as tragic if I did them in the wrong order. What's usually the problem is with division, let's see, if I just do like another example. Okay, if I do 18 divided by 2 times 3. If I do the multiplication first, this is going to be 18 divided by 6, which would give me 3. But if I do the division first, this is going to be 9 times 3, which is 27. So you can see that makes a huge difference, right? One answer is 3, the other answer is 27. The correct answer is 27. Okay. So in this example, because they were separated by addition, it's not so vital. But over here, it makes like a world of difference. So just be careful. When this happens, we want to start in the most inside. So this is the, step 1 is going to be the inside parentheses. So you start, like if you have parentheses inside of brackets and then maybe more parentheses and you got all this stuff going on, you want to go to the furthest inside and then work your way out. Okay, so this is going to be 5 squared. Okay, now I still have to work inside the brackets because that's a grouping symbol, and inside the brackets the exponent comes next. Okay, then I subtract inside the brackets. And then I multiply. As I mentioned before, a fraction bar is a grouping symbol, so this is splitting this problem into 2 groups, a top group and a bottom group. So what we can do is we can concurrently work the top and the bottom. We can work them at the same time, but we work them separately, if that makes sense. So in the numerator, we're going to do the exponent. And in the denominator, we're going to subtract. So it's going to give me 4 minus 5 over 15 minus 9, which is 6. Then we'll subtract in the numerator. And we don't really have anything to do in the denominator, so I get negative 1 over 6. And then the last step would be to reduce or divide if necessary. Okay. This is already reduced. And unless I ask you specifically for a decimal answer, there's no need to divide it. Just leave it a fraction and you're done. So that's why I put the if necessary. Okay. whenever you talk about, there's evaluate, simplify, and solve are the three main things that you'll have to do. Evaluate means to plug in Okay, so evaluate is to plug in given values and then simplify. Okay. Simplifying is to reduce things down to their smallest capable units. And then obviously solve is to find out what the variables equal. But we're not solving this because we're being told what the variables equal. So what we need to do is we need to plug in the given values. So x is 4, so instead of 3x squared, I'm going to have 3 times 4 squared plus 2y, y is 5, plus z to the third, so that's 3 to the third. Step 2, we have to work inside the parentheses, so I'm going to do the multiplication and the exponent inside the parentheses. Now, I could have also done this exponent at the same time because it's completely separate, but I didn't. So next, I'm going to add inside the parentheses, and I'm going to do the exponent outside of the parentheses. So 4 squared, 16. And then lastly, I'm going to multiply and then add. Okay, so 3 times 16 is 48. 48 plus 37 is 85. There's a difference between this and that. Exponents, this is a terrible example, but I feel that it gets the point across. Exponents are like a taser, right? Like if I tase you and I stick that thing on you, right, it's only going to shock you. It's not going to shock the guy standing next to you unless you're holding hands. So if you're in a parenthesis together and you're holding hands and I tase you, then it will also shock the person that you're touching, right? Exponents only affect the thing that they're directly touching. So in this top example, the 4 is only touching the 3. It's not including the negative. So this is going to be negative. Here, the 4 is touching the parentheses, and the parentheses are encompassing the whole thing. So here, the negative is being taken to the power of 4 as well. So that would be positive 81. So that's really important. So what I have is even exponents. Actually, if I have a negative number to an even exponent, it gives me a positive answer. And if I have a negative number to an odd exponent, it gives me a negative answer. Okay, so that's just a nice little trick so that you don't have to, when you're entering exponents into your calculator or doing a bunch of multiplication in a row, you don't have to think about the negative. You can just look at the exponent and go, oh, it's even, my answer is going to be positive, and you can let it go. Okay, so here I'm going to have a positive 81. Down here, I've got a negative to an odd. So negative 5 to the third is going to give me a negative 125. 5 times 5 is 25 times 5 is 125. Okay. I have negative 3 times positive 4, so that's negative 12, times negative 5, so that's positive 60. And then 2 plus 4 is 8. Thank you. I looked at the light. 81 and 60 is 141. Negative 125 plus 8 is negative 117. $141 adds up to 6. 1 plus 4 plus 1 is 6. 117, so 7 plus 1 plus 1 is 9. So these will both divide by 3. Do you guys know that rule? Okay, quick. If you add up the digits of the number, and if the sum, so 1 plus 4 plus 1 is 6, 6 divides by 3, so 141 will also divide by 3. So that's just a quick way to know if something will divide by 3. 2, to divide by 2, it has to end in an even number, so 0, 2, 4, 6, or 8. To divide by 5, ends in 5 or 0. Ends in 0, you can divide it by 10. And then to divide by 4, if the last 2 digits divide by 4, the whole thing will, but if it'll divide by 4, it'll divide by 2, so it's not that important. Okay, so this will divide by 3, and this will divide by 3. If I have a negative in the denominator, I just make the whole fraction negative. So that's going to be 37, and this is going to be 39. And 37 and 39 won't divide by anything in common. So.
8 and
Yes.
141 divided by 3 is in 37. 37.
Yeah, look. 3 goes into 14. 3 times. Oh, 4 times. 47. Sorry. Thank you. Oh, shoot. Okay. Yes, you're right. It's 47. Oh, which makes it still dividable. Good catch. You get extra credit. By the way, when you catch my mistakes, you get extra credit. I do make them. Everybody does. Okay, 47, 4 plus 7. No, it's not. It's still dividable, actually. Yeah, okay. So 47 over 39. All right, so the volume of a cone is 1/3 pi r squared h, but that can also be written as pi r squared h over 3. So that's pi r squared h divided by 3, and then you're not really dealing with a fraction anymore. You're dealing with division, and I believe, maybe incorrectly, but I believe you guys prefer division to fractions. Okay. All right, pi, for all intents and purposes, when we use pi for, we use 3.14. You don't need any more digits than that. So we're going to plug in our values. We have a height and we have a radius. They're both meters, so we're good. We don't have to change anything. So I have pi. I have a radius. gonna have a height. Okay, and you guys all know 75 squared, right? Don't have it memorized. Okay, so 75 squared is 5,625. And if I multiply all of this together, $3,974,062.5. And then I divide that by 3. And I get 1,324,687.5 meters cubed. Volume is always cubed. So inside the real numbers, the smallest set of real numbers are the natural numbers. Okay. Now they're infinite, but they start at 1. There's no negatives. And they're also known as the counting numbers, because it's just the numbers you get when you count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on up through a gazillion and a billion and Googleplex, and just keep going forever. They go forever and ever and ever, and that's what these dots symbolize. Make them bigger so you can see them. They're symbolized with either an N with 2 lines, or again, you can bold it. But you have to make sure you mean it to be really bold. Okay. I usually just do the second line. So that's the smallest set. And have you guys ever seen those wooden dolls, the Russian dolls that stack inside each other? This is the little tiny baby doll that's on the very inside. Okay. The next set of real numbers you get are the whole numbers. And they're just like the natural numbers, except we add 0 to it. And then it goes forever. So this one starts 1, 2, 3, 4, 5, 6, 7. We go 0, 1, 2, 3, 4, 5, 6, 7. So they're 1 bigger. And that's symbolized with a W, with either an extra line like that or a really bold W. Okay. So that's the next biggest doll in the Russian doll stack. Then in the next doll up are the integers. Okay. And what we've added at this point is we add negatives. So we're still kind of whole number-ish. So we're all the whole numbers, but then we're also all the opposites. So we don't have any fractions, we don't have any decimals, we're just numbers, we just happen to be positive and negative. And we go in both directions now infinitely. The natural numbers and the whole numbers only go in one direction infinitely. They have an end on the one side, whereas the integers have no end on either side. They go in both directions infinitely. And those are symbolized with a Z. And the Z is kind of like, I didn't draw that right. double, like that, or bold. Okay. Then the next largest doll, those are the rational numbers. Okay. And the definition of a rational number is a number that can be written as a fraction. Okay? So we have fractions. Okay. We have all the integers and the whole numbers and the natural numbers because they all fit inside the same doll, right? And then we have decimals that end or repeat. Okay. So that's like 0.25, and then it's just done. Or 0.33333 forever and ever and ever, because repeating decimals can be written as fractions, because 0.33333 repeating forever is 1/3. So these are numbers that can be written as fractions. So that's like the strictest definition, but it helps better, I think, to know that it's fractions, integers, and decimals that end or repeat, and it's perfect square roots also. We might want to write that. Perfect roots. So like the square root of 4, because that's 2. Okay. The symbol for the rational numbers is a Q with a line, or a Q that's bold. Okay. Now, what we have is, if you have your traditional nesting dolls, right? You have this one little doll, and the next doll, and the next doll, and then this is the big doll on the outside is the real numbers. And in a normal wooden doll, that's all you have, but in our weird doll, we have this strange sort of crazy cousin doll that hangs out inside the big real number doll. So that's this white box over here. These are real numbers, but they don't fit inside these pretty stacking boxes. This is like your crazy, weird uncle that's in your family, but doesn't really fit. Anybody have a crazy, weird uncle like that? Your cousin, aunt, eccentric great-grandma, something like that. Anyway, this is the eccentric cousin. These are the irrational numbers. Okay. Now, irrational numbers are non-ending, non-repeating decimals and non-perfect roots. And non-perfect roots are non-repeating, non-ending decimals. So pi, right? You guys all know pi goes on forever and has no pattern and has no end. Pi is an irrational number. So any decimal that will go on forever and ever and ever, and it has no pattern, it has no end, would be considered irrational. The square root of 2, because it's not a perfect square, it's going to give me some decimal that goes on forever and ever without any end. So that's also irrational. Square root of 2 is irrational. Square root of 5, square root of 3, square root of 4 would be over here. But the square root of 7, you know, all the square roots that are not perfect squares. All the cube roots that are not perfect cubes, things like that, these are all going to be irrational. So they're in the same family, they're real numbers, but they don't really fit in. I know. this is the normal family, and this is the gothic kid. Right? I don't think anybody's gothic anymore. Okay, this is the emo kid. And I say don't use real because they're all real numbers. And so you just write real for everything, and that doesn't really tell me you understood anything. Does that make sense? So if we look at A is negative 23. Okay. Natural and whole numbers have no negatives. Right? So if you're looking at your little chart, natural and whole numbers have no negatives. So the first category that these will fit in would be integers. Well, if it's an integer, it's also rational, and they're all real. So I'm not even going to write that, but they're all real. So you don't have to write real numbers because they're all going to be real. So they're both integers and rational. Actually, I want you to put integer. I want you to put the smallest number they fit into. Does that make sense? Because that way I know that you understood. Okay, the square root of 50. Is this a perfect square? 25 is a perfect square, so I can take that out, but I'm going to have 5 times the square root of 2. So see, it's still not a perfect square. If it's not a perfect square, it's irrational. So you can either do like the bold I. Oh, I didn't tell you guys the symbol for this, did I? No, I didn't. Okay, irrational numbers is either a bold I or the Q with an apostrophe. Sorry, I meant to do that. So bold I or Q with an apostrophe. I think the bold I is a little bit more clear because the Q with apostrophe might. So it's irrational, it's also real. Negative 4/9. I can't simplify it, but it is a fraction, which makes it rational. Okay, 15/3, if you divide that, you get 5. So this is a natural number, a whole number, an integer, and a rational number.
Whoa.
So it's all of them. On your homework, I'd want you to put natural, because natural is the smallest category it fits in. Does that make sense? So on your homework for this one, I'd say to put integer. For this one, put natural. Negative 185, it's negative. So it's an integer, and it's rational. And then square root of 49. 7, right? So that's 7 is a natural number. We can count to it, so that makes it also whole. And an integer and rational, but on your homework you could just say natural. I'm going to use letters on here. This is just for all real numbers. Okay, so technically I should be using just letters because that symbolizes that it could be any real number. I'm just going to use numbers because I feel like it's easier for you to picture that way. So the commutative property of addition tells me that 2 plus 3 is the same thing as 3 plus 2. Does not matter what order I add in, I get the same answer, right? And I can replace this 2 and 3 with any numbers, any real numbers, any fraction, any decimal, anything, and it'll still be true. Okay, multiplication tells me that 2 times 3 is the same thing as 3 times 2. It does not matter what order I multiply in. Now you'll notice subtraction and division are not up there. And that's because it's not true anymore for subtraction or division. It's only true for addition and multiplication. And that's the case with all of these properties. So with the associative property, so this is, commutative property is the order, associative property are groups. Associations are groups, right? the National Association of Women, that's a group of women. You have the American Heart Association, that's a group of heart doctors. Okay, so it doesn't matter with addition which group I do first. This is 1 plus 5, which is 6. This is 3 plus 3, which is 6. So when I group things, it doesn't matter. That's just like if I grouped you guys by half the students on the right and half the students on the left, or I grouped you by boys and girls, it's still the same number of people. Does that make sense? Same thing with multiplication. One times 6 is the same thing as 2 times 3. So, and like I said, any numbers can be substituted in for those. It's just still going to be true. Okay. Your identity is who you are. So the identity property does not change the identity of the number. So we're going to say no change. So if we're talking adding, what can I add to a number that won't change anything? 0. Okay, 0 is known as the additive identity. It's the additive identity because it didn't change anything. And for multiplication, it's 1. And that's called the multiplicative. So we have the additive identity and the multiplicative identity. So it's just the number that you can add or multiply by that doesn't change anything. So 0 and 1. Okay, inverse does not have that many e's in it. So we're going to take this one out because it doesn't belong there. Sorry, typo. Okay, inverse is to get the identity. Okay, so if I were to take a number 3, I want to know what number do I add to 3 to make it a 0. Well, I would add negative 3. So when you're talking about addition, the inverses are opposites. Okay, so 3 and negative 3 are inverses of each other. They're opposite signs. For multiplication, I want to get to a 1, and so what I multiply by is be 1/3. Or if I had a fraction, I'm going to write this off to the side. I'll write it up here. Okay. 2/3 times 3/2 would equal 1. So if you have a whole number, it's 1 over that number. If you have a fraction, it's the reciprocal. In both cases, they're the reciprocal. So your inverses for multiplication are reciprocals. So addition is opposites, multiplication is reciprocals. Okay. Closure just is kind of a silly thing, actually, to worry about at this stage. But closure just means that if I take two numbers, if I add two real numbers, it equals a real number. So I'm not going to add two numbers together and get an imaginary number. Okay, same with multiplication. If I multiply Now, and this is for any of the categories of real numbers. If I add two whole numbers, I get a whole number. If I add two natural numbers, I get a natural number. If I add two rationals, I get a rational. Same with multiplication. What doesn't happen is division. Division's not closed all the way. Like if I divide two whole numbers, I don't necessarily get a whole number. I could get a fraction, right? So that's why it's just addition and multiplication. And finally, distributive property. You guys have done this. I distribute the multiplication. Technically speaking, this is the distributive property of multiplication over addition. But we just call it the distributive property because we're lazy. What you want to do is you want to say, okay, what changed between here and here? The order is the same, 5, 4, 13, 5, 4, 13. The only thing that moved was the parentheses. If the parentheses are the only thing that moved, that's the associative property. Okay. Here, I have 5 plus 7, and then I have 7 plus 5. So the order changed. So that's the commutative property. Okay. 5 plus 0 equals 5. Really nothing changed, right? So that's the identity. Oops, I'm my own way. Okay. Finding the additive and multiplicative inverses. Okay, additive, opposite. This is positive, so my additive is negative. Multiplicative is reciprocal, so I had 2/3, so I flip it over. 3 halves. I can do that. -4. Okay, it's negative, so my additive inverse is the opposite, so that's positive. And my multiplicative is the reciprocal, same sign, just flip it over. Yeah. When you have a decimal, additive is really easy still. It's just the opposite, so it's going to be negative. The multiplicative is going to take a little bit more work. So I'm going to come over here, and 1.24 is the same thing as 124 over 100. The number of decimal places you have tells you how many zeros. So 2 decimal places, 2 zeros, and then I can reduce this, and it reduces to 62 over 50, which then reduces to 31 over 25. So my multiplicative is 25 over 31. So that one's going to take a little bit more work. So I'm going to distribute that 3, and I'm going to distribute this 5. So 3 times 2q is 6q, and then 3 times r is 3r. And 5 times 4q is 20q, and 5 times -7r is -35r. And then this next step you can do or not. I like to rearrange things so that they're next to each other, but you don't have to. What I did there was the commutative property. Very exciting. Then I add them together. questions on that? Now, one thing, be careful, -2. You are not distributing a 2, you are distributing a -2. So be really careful about that. So the negative has to go to both. So I have 16x minus 8y minus 6x minus 2y. So it's -2 times 3x, -2 times y. So that's 10x minus 10y. Yes, I